Okay, welcome to another video in my Wild Networking series where we learn about and practice network engineering with the intention of doing it in the wild and focusing on the sorts of things you would see in the wild, such as on the job or such a for knowledge that you'd more be expected to know for job performance, entrepreneurship, what have you, as opposed to in the classroom or on a test. So I will shrink my screen and share a browser here. So what I've been doing is reading the BGP RFC, and the reason I've been doing that is because I recently took the JNCI ESP and I just really did worse on it than I ever kind of imagined I would. And perhaps some of that was more due to me being having taken my first expert level exam, and just having kind of unique experiences. There being taking it, not going to a test center. I was expecting to take it under certain circumstances. I mean, I don't think that would, and in fact, I think that might even help me be an advantage in some way. But the test kind of exposed a lot of weaknesses I had in my understanding of BGP. And as I'm going through and reading the RFC, which is something I didn't do before taking the test, I just had to kind of manage my time. I was studying about 2 hours a day, and already I've got hours and hours of video for me reading this. So I just didn't know if this was an efficient way to learn about the elements of BGP required for the test. So I went back because I believe really strongly in foundational knowledge, and I thought I had that built up pretty strongly from my earlier certs, the JNCI S and P, but it turned out I really did not. I just kind of I had some flaws in my learning. So that's what I was going to do here, and thinking more about that. That's really, I don't think, kind of appropriate for this series, because this really isn't wild networking in some ways, because I just don't think learning every little detail and discussing specific points in an RFC is necessarily something you'll see in the wild. I guess actually no, I disagree with that. I think if you're going to be effective on the job, using RFCs is a great place to start. So I actually completely disagree with that, but that's something I had thought about when I started this video and wanted to kind of come to terms with, because there are and I need to take a quick break. I'll be back soon. Okay, I'm back. Sorry about that break. This is a rare early morning video. So I believe I was talking about just kind of the decisions I've been making for this wild networking series on what to cover, and kind of having some doubts, because I just took a expert level exam, so that's really where my mind is right now. But if I were to in earnest to talk about what I see in the wild, I can't exactly do that either. I do in some ways need to focus on what you would see in even then in an exam. But what I'm saying is that just like for the JNCI ESP, where I signed a confidentiality agreement to not talk about the actual exam in any specific way, except for what is made public about it, such as the publicly posted curriculum. But even then, the actual curriculum that I saw on the exam, I can't talk about at all. Only the publicly posted one, whether it is accurate or not. And if it is inaccurate, the only thing I can do is email the test designers and let them know my opinions on the test if they are negative. Making a public video where I say that something like that, from what I understand, would be in violation of that agreement. So I bring that up because if I were to do a true wild networking series and talk about, you know, some things I saw in the wild, I could possibly be kind of teetering on that sort of thing as well. I'm not sure if I specifically signed anything. Well, let me stop there and just say that this series is not meant to be, you know, discussing confidential scenarios I see, you know, on the job that you know, a company could object to me talking about. That's not at all what this series is meant to be about. So I think reading the RFC is really a good thing to do for this series. It's so I'm going to continue doing that, but I do have my doubts on this because it is, I think, in a lot of ways irrelevant to the real world. I just think when you're on the job, you can bring more value to the job if you learn like a blend of coding. You can make generators. Like if you can just sit down and in an hour build a tool that just saves everyone, you know, an hour of work or even 10 minutes of work. If you get to the job, the first 2 weeks you see everyone's, you know, doing this thing that it's crazy. Why are they doing this crazy thing when you can just sit down in 5 minutes and write a script to have the script do it instead? If you can do that, you are in the door. They you know, you're basically a god with magic powers in some way if you can do it really well. And that's something I want to get better at, because if we're talking about network engineering in the wild, my recommendation to anyone watching this series and how I think I can bring the most value just to the general community of network engineers or people aspiring to be network engineers is talking about that sort of thing. Config generators, automatic configuration of devices. Another thing that I think is often overlooked in if we Google right now Python network engineering, and we get like some sort, yeah, so here's a tutorial here, read the docs. I don't think we're going to get yeah, see, we're just getting specifics about how to write code. And that's something that I think, of course, it's important. You know, if you ride the bike, you know, you got to know how to ride a bike before you can call yourself a cyclist. But there's more than that. You need to know what the fines are for not wearing a helmet, and you need to, you know, make those decisions. Do I wear a helmet? Do I not wear a helmet? Do I how can I ride on the sidewalk, or do I have to ride in the street? Those sorts of things are, I found, the main difficulty in coding on the job, and that's something that basically no tutorial will walk you through. Just knowing what the business actually wants from you, and how to implement that in a way that the business, I guess in a way that is acceptable to the business, because, you know, we could potentially be talking about, I mean, here we're talking about, let's see here, but I mean, if we're talking about configuring a network engineering device, you know, we could be talking about a secure secure systems that the device reaches out to. Like if it reaches out to a logging server, or reaches out to a TACX server, those might be systems that aren't under your purview. So one thing that is, I think, missing a lot from these is how to kind of request access that you might not normally be given under your job, but that you're going to need to effectively implement network automation. The most clearest thing, and this is something you'll absolutely, if you're going to do network automation, this is basically the first thing you're going to need, is a development server. So you basically need your own computer, and where it gets tricky is, you'll have your own computer, of course. Any tech job you get, you're going to be working on a computer. But do you have the level of access on your computer that you need? Because you're going to need, if you're automating something, you're going to need to, one, be able to reach the device from a launching point where you can run code. Just speaking broadly, and not to anything I've specifically seen, because I want to be careful about that. But broad, I think some broad network engineering. Well, there's something called a jump host, yeah. So it's an intermediary host or SSH gateway to a remote network, and this is in a DMZ, a demilitarized zone. So if you're, if you have your laptop and you're working in an office or you're working at home, sometimes, depending on what the business needs of the company are, logging into a device directly from your laptop is highly discouraged, because your laptop is not in this demilitarized zone where they have these intermediary hosts or SSH gateways to the remote network. So, and you might even have it so that there's a restriction, a firewall, where even if you wanted to connect with your laptop, you can't even do that, because they're really, this network you're meant to work on is just really highly confidential, highly locked down, highly secure, and you're not meant to access it except from a point that is set up specifically for access. So this is where automation for network engineering gets really difficult. And this is where any tutorial you find basically won't ever talk about this, as far as what I understood, because you need to get your modules on there. You need to get the things you need to automate. If you don't have Python on this server, you can't use Python. If you have Python, but it's version 1.0, you got to get that upgraded. And that server might not necessarily have access to the public internet. In fact, I can probably guarantee you it won't if you're in some sort of situation like that. So that's the thing. That's kind of where I'd like to take this series more, is like, what is the most effective thing you can do on the job on day one to really kind of solidify your value to the company, and what are some things that you need to do that are consistently missing from widely available technical documentation, such as this read the docs. Now, of course, if you jump on Amazon, and I think even in this book, I'm doing another series where I read this book, and I'd like to, hopefully I can get some time on that this morning as well. But if we jump over to the table of contents in this book, there are some you can find professional, you can find that sort of thing, but kind of one place I would like to take this series eventually I would like to take this series there eventually, even though, I'm definitely not at the same level as somebody who like published a book or something like that. But it's timely. I'm out there. I'm not going to be talking about anything I specifically saw, but I will be talking about where I think a tutorial like this needs extra explanation and why. As I did with that idea that you may need to do interpersonal social things on the job in order to allow you to do technical things. They kind of go hand in hand. You've got to talk to the specific people. You've got to use the right language too, because if you really sour a relationship with someone and they kind of don't believe you have good intentions, they're not you're not going to get as far with what you need to do, or at least not as timely. You'll need to go through a lot more barriers than if you can go through. If there is an official process, you can follow that process. You can, and then this is where things get really tricky, because sometimes official processes really aren't updated and rethought, and are just kind of relics of an older time, and getting those either updated or knowing how to, when it is appropriate to circumvent or go around a barrier, I think is something that's missing from these sorts of tutorials, and really has to be there. Is when I'm writing this groundbreaking revolutionary code that's going to change everything in this department, how do I change things that are considered kind of sacred, holy, and not meant to be changed, especially if I'm new on the job. And if there is something like that, how can I develop my code if for example, that is a jump host that's not allowed to have any Python on it or anything like that? How can I go about network automation if I'm not allowed to have the appropriate tools? So, in my opinion, the best way to do that would be to, first of all, explain why you need it and communicate that effectively. And that's just completely outside of the realm of technical proficiency, but it is an important skill in the wild. It's just those communicational skills, and aside from the technical aspect, the interpersonal communicational kind of relationship building aspect, where you kind of can. I mean, it's hard for me to explain it, and to be honest, it's probably one of my weaker things. I really enjoy kind of going in deep and learning the hands-on technical elements. So this has been something I've struggled with, where if I had just communicated in a different way, or if I can, I think oftentimes I could be more effective if I learned about that side of things a little bit more than just the technical sides of things. So that's one thing I want to bring to this series, in case other people struggle with that. And I know in this sort of job where you really don't get in the door unless you know the technical side, and you really don't know the technical side unless you kind of you have a lot of quiet study time to yourself, and you're really not, I think, to the same level as people in non-technical fields engaged in social activity. It can be really hard for technical people to do that in a lot of cases, but it ends up being really important. And of course that's where managers come in. You can you don't have to just march into the CEO's office and say, I need this, and that. You communicate with your manager. That's where things start. Okay, so yeah, let's continue reading the RFC. So I pulled up my channel here because I want to see where I left off. The other thing I wanted to touch on, and sorry, I'm already 20 minutes in here, and I haven't accomplished any more of reading the RFC yet. But let me see where I left off. I don't understand why I can't see. Okay, I left off on section 6.3. So I will start reading that shortly, but before I do that, I just wanted to kind of bring attention to the fact that I, am published in an RFC now. My name is here. I think that's really exciting. So if you're reading the official BGP RFC, just click errata. You can come over here and see I've got a errata ID for my report, and it's a technical report, and it's a valid report marked here by the reviewer in their verifier notes, and it's what I talked about in a previous video where I believe local preference is well-known and discretionary, but the official stance on that by I guess, I don't know, if the people who write these RFCs, is that it's really not well-known discretionary. It's more well-known mandatory, because although a router can, although it's dependent on whether there's an IBGP or EBGP connection. For an IBGP connection, you have to have a local pref, and for an EBGP, you can't have a local pref. In all of those cases, it is mandatory what you do. So you can't say this is a EBGP connection, but I can choose whether or not to include it. No, if it's EBGP, you cannot include it. Same thing for IBGP. You don't have a choice whether or not it's in there. You have to include it in an IBGP update message. But kind of where I thought it was discretionary is you do have the discretion to set up an EBGP or an IBGP neighborship on a router. But even then, if your router is serving a certain role in your network architecture, in your autonomous system, you don't have that discretion. It's dependent on the role. So there's definitely a matter for debate there. It's unclear whether this is well-known mandatory, well-known discretionary, or in its own category. So they mark this as a valid report because they just need to, in future RFCs or a future revision of this, use clearer terms. And this is a good, clear response to this. There was another errata, and we saw kind of the response was unrelated to that, and then the errata itself calling for a fifth category. I'm just not sure that's the best way to do it. I think the best way is to actually determine what the local pref attribute actually is. And I think I would argue for it being well-known discretionary, but I think I would understand the argument for it being well-known mandatory, and could accept a consensus on that. But I would personally offer up an opinion for it being. I would personally want it to be well-known discretionary, because I think it is easier to consider it as part of that category. But the argument against it is that if you call it well-known discretionary, somebody could get confused and not understand that for IBGP it's always necessary, and for EBGP it's always not necessary. It's always going to be included. The word shall is a technical term, it has to be included, and similarly for EBGP. So understanding that it's an update that does have to be included, and it's not like the MED where sometimes you can add it, sometimes you can't, depending on what you're doing. That's the characteristic of a mandatory attribute. So I definitely understand with that argument, and if there were a consensus leaning towards that, I could definitely accept that consensus. But if you were to ask me specifically which one I would want to argue for if we were having a debate, I would pick well-known discretionary. Okay, so let's move on to 6.3, and hopefully we'll get all the way to 7. That would be wonderful if I could do that. It's a little bit ambitious, but let's get started. This is update message error handling. All errors detected while processing the update message must be indicated by sending the notification message with the error code update message error. The error subcode elaborates on the specific nature of the error. Error fact-checking of an update message begins by examining the path attributes. If the withdrawn route's length or total attribute length is too large, for example, if withdrawn route's length plus total attribute length plus 23, because the length fields have a length separate from the value of that field. So what you have is you have a field in the packet or the update message that tells you how long another field is. So that first field, field A, with that value of field B, is going to have a length value as well. For example, 1 octet long. But in addition to field A being 1 octet long, field B is going to be a length as well. That length will be given in the value of field A. And that's where this 23 comes in, because you've got to add up all of those required static fields that don't change from update to update, and include that in your calculations for the total length. So you've got to include your variable lengths, and then your static lengths, such as the length of your length fields. Okay, so for example, if withdrawn route's length, the variable field, which could be a variable length, plus total attribute length, which can be a variable length, which 23 exceeds the message length, and 23 stands for those static parts, such as the length of the length field. Then the error subcode must be set to malformed attribute list. If any recognized attribute has attribute flags that conflict with the attribute type code, then the error subcode must be set to attribute flags error. The data field must contain the erroneous attribute, type, length, and value. If any recognized attribute has an attribute length that conflicts with the expected length based on the attribute type code, then the error subcode must be set to attribute length error. The data field must contain the erroneous attribute, type, length, and value. If any of the well-known mandatory attributes are not present, then the error subcode must be set to missing well-known attribute. The data field must contain the attribute type code of the missing well-known attribute. If any of the well-known mandatory attributes are not recognized, then the error subcode must be set to unrecognized well-known attribute. The data field must contain the unrecognized attribute, type, length, and value. If the origin attribute has an undefined value, then the error subcode must be set to invalid origin attribute. The data field must contain the unrecognized attribute, type, length, and value. If the next hop attribute field is syntactically incorrect, then the error subcode must be set to invalid next hop attribute. The data field must contain the incorrect attribute, type, length, and value. Syntactic correctness means that the next hop attribute represents a valid IP host address. The IP address in the next hop must meet the following criteria to be considered semantically correct versus syntactically correct. In order to be considered semantically correct or semantically incorrect, it must be syntactically correct. But the criteria for considering it to be semantically correct is A, it must not be the IP address of the receiving speaker. B, in the case of an eBGP, where the sender and receiver are one IP hop away from each other, either the IP address in the next hop must be the sender's IP address that is used to establish the BGP connection, or the interface associated with the next hop IP address must share a common subnet with the receiving BGP speaker. If the next hop attribute is semantically incorrect, the error should be logged and the route should be ignored. In this case, a notification message should not be sent and the connection should not be closed. The AS path attribute is checked for syntactic correctness. If the path is syntactically incorrect, then the error subcode must be set to malformed AS path. If the update message is received from an external peer, the local system may check whether the leftmost with respect to the position of octets in the protocol message AS in the AS path attribute is equal to the autonomous system number of the peer that sent the message. If the check determines this is not the case, the error subcode must be set to malformed AS path. If an optional attribute is recognized, then the value of this attribute must be checked. If an error is detected, the attribute must be discarded, and the error subcode must be set to optional attribute error. The data field must contain the attribute type, length, and value. If any attribute appears more than once in the update message, then the error subcode must be set to malformed attribute list. The NLRI field in the update message is checked for syntactic validity. If the field is syntactically incorrect, then the error subcode must be set to invalid network field. If a prefix in the NLRI field is semantically incorrect, for example, an unexpected multicast IP address, an error should be logged locally, and the prefix should be ignored. An update message that contains correct path attributes, but no NLRI, shall be treated as a valid update message. So shall is just another term for must. So it must be treated as a valid update message. Which is kind of, I think, counterintuitive, because I think the official... Yeah, so we can see the colloquial, the definition that is most commonly used by people. And you can see it's declining all the time, so it's just not the best word. I think must is a much better word. But it's expressing a strong assertion. So it's really not the right word, because shall means strong, you must do it, but you have the option of not doing it. It's just that option is not a good option. But must, you don't have the option. You got to do it. And in technical documentation, they need to be clear about that. So in the definition of terms RFC, they state explicitly shall means must. They have the same meanings in this context. Of course, in a colloquial context where you just speak day to day, the word shall does have a different meaning. Section 6.4, notification message error handling. If a peer sends a notification message and the receiver of the message detects an error in that message, the receiver cannot use the notification message to report this error back to the peer. Any such error, for example, an unrecognized error code or error subcode, should be noticed, logged locally, and brought to the attention of the administration of the peer. The means to do this, however, lies outside the scope of this document. Section 6.5, hold timer expired error handling. If a system does not receive successive keep alive, update, and or notification messages within the period specified in the hold time field of the open message, then the notification message with the hold timer expired error code is sent and the BGP connection is closed. Section 6.6, finite state error handling. Okay, and we saw this one. We saw this error message. I would like to see these, but it's hard to get some of these. The routing gear is set up specifically so that you don't get these messages. Otherwise, there's something really bad going on if you get one of these messages. The finite state machine error handling message is any error detected by the BGP finite state machine. For example, receipt of an unexpected event is indicated by sending the notification message with the error code finite state machine error. The cease message in the absence of any fatal errors that are indicated in this section. A BGP peer may choose at any given time to close its BGP connection by sending the notification message with the error code cease. However, the cease notification message must not be used when a fatal error indicated by this section does exist. A BGP speaker may support the ability to impose a locally configured upper bound on the number of address prefixes the speaker is willing to accept from a neighbor. When the upper bound is reached, the speaker, under control of local configuration, either A, discards new address prefixes from the neighbor while maintaining the BGP connection with the neighbor, or B, terminates the BGP connection with the neighbor. If the BGP speaker decides to terminate its BGP connection with a neighbor because the number of address prefixes received from the neighbor exceeds the locally configured upper bound, then the speaker must send the neighbor a notification message with the error code cease. The speaker may also log this locally. Alright, section 6.8, BGP connection collision detection. Now this, I think I know a lot about. This, yeah, okay, this is good. This is good because I saw this in the wild, or not in the wild, but I saw this in my lab. And this is a potato. I'm sorry, I shouldn't just have half-eaten food in this. I just kind of feel better. I can hold the potato off camera. All right, but let me ignore this potato here and continue to read this. So BGP connection collision detection. I'm just getting excited because this is the official explanation of something I have seen. If a pair of BGP speakers try to establish a BGP connection with each other simultaneously, then two parallel connections will be formed, W-E-L-L. If the source, I'm sorry, if the source IP address used by one of these connections is the same as the destination IP address used by the other, and the destination IP address used by the first connection is the same as the source IP address used by the other, connection collision has occurred. And we saw this in my training series for the JNCI ESP. I just didn't know this was a part of the RFC at the time. In the event of connection collision, one of the connections must be closed. Based on the value of the BGP identifier, a convention is established for detecting which BGP connection is to be preserved when a collision occurs. The convention is to compare the BGP identifiers of the peers involved in the collision and to retain only the connection initiated by the BGP speaker with the higher valued BGP identifier. Upon receipt of an open message, the local system must examine all of its connections that are in the open confirmed state. A BGP speaker may also examine connections in an open sent state if it knows the BGP identifier of the peer by means outside of the protocol. If among these connections there is a connection to a remote BGP speaker whose BGP identifier equals the one in the open message, and this connection collides with the connection over which the update message is received, then the local system performs the following collision resolution procedure. Number 1, the BGP identifier of the local system is compared to the BGP identifier of the remote system as specified in the open message. Comparing BGP identifiers is done by converting them into host byte order and treating them as a 4-octet unsigned integers. Wow, okay. If the value of the local BGP identifier is less than the remote one, the local system closes the BGP connection that already wins. So the higher one is the one that wins, the lower one backs off. The one that is already in the open confirmed state and accepts the BGP connection initiated by the remote system that has the higher BGP identifier when you convert all 4 octets into one number. And compare that to the other one. So for example, you have I guess an example isn't necessary, but I wanted to just make it clear that let's say you have one that is 100.100.100.100, and then you have another one that is 99.99.99.200. So it's actually going to be that second one that is the higher one, because even though 3 out of the 4 octets are lower, when you drop the dots and you convert that into one bigger number, wait, no, it's going to be the higher one that's higher then, right? Yeah, actually, I think that's true. I don't know. I'm confused about that. I think it's going to be the 100.100 address is going to be the higher address than the. Yeah, because those but if you were to have, let's say 200.1.1.1.1, that's going to be a higher address than 1.200.200.200.200, because even though those 3 octets are higher than the other ones, their order matters. So the beginning is where you get the highest number. So the more bits you have at the beginning, the bigger your number is. But the more bits you have at the end, yes, the bigger your number is as well, but at a different scale. So that's what I believe it means when they are converted to. Oh, I see, but only the host portions. Host byte order, what does that mean? Treating them as 4 octet. Oh, okay, okay. It just says that all bits are considered as host bits. So yeah, I think I was right that it's the leftmost numbers being higher, and even if the numbers on the right are higher, those count for less. If the value, oh okay, I think I read that second one already, so let's go on to the third one. Otherwise, the local system closes the newly created BGP connection, the one associated with the newly received open message, and continues to use the existing one, the one that is already in the open confirmed state. Unless allowed via configuration, a connection collision with an existing BGP connection that is in the established state causes closing of the newly created connection. Note that a connection collision cannot be detected with connections that are in idle, connect, or active states. Closing the BGP connection that results from the collision resolution procedure is accomplished by sending the notification message with the error code cease. Okay, I made it to my goal, which, oh, well, let's set the goal up to 8 because the section 7 is so small. Section 7 is BGP version negotiation. BGP speakers may negotiate the version of the protocol by making multiple attempts at opening a BGP connection, starting with the highest version number each BGP speaker supports. If an open attempt fails with an error code, open message error, and an error subcode unsupported version number, then the BGP speaker has available the version number it tried, the version number its peer tried, the version number passed by its peer in the notification message, and the version numbers it supports. If the two peers do support one or more common versions, then this will allow them to rapidly determine the highest common version. In order to support BGP version negotiation, future versions of BGP must retain the format of the open and notification messages. Okay, so here's section 8. Section 8 is I guess it's not too bad, but I want to read that other book I've got, and I can do probably a full half hour on that if I stop here. So this has already been 45 minutes, which is a pretty long video. Granted, it's really only been like 15 minutes because I wasted a lot of time at the beginning, just kind of discussing how I want this series to go and my doubts with focusing so much on the RFC, but. I think eventually I'm going to get through it if I keep reading it, so I'm going to keep working towards that, just get through it, and then after there kind of reassess where I'm at and where I want to go with this series. But thanks for watching. I'll see you in the next wild networking video.